Hello and welcome to this video on logarithms. So we've already done a part one. This is just developing into the chapter a bit. Now, if we just recap these logarithm questions a bit, if we had 2 to the power of x equals 72, how would you solve it? Well, x is at the power right now. How would you get rid of that 2 that's sort of in front of x? Well, you take log 2's of both sides. Okay, I'm gonna take log 2's of both sides, as you call it. That will get rid of the 2, and you're just left with log base 2 of 72. Okay, and then you can put that in your calculator, and that might be whatever. So with e to the power of x, it's exactly the same thing. Just like we took log 2's of both sides in the first question, we're just going to take log e's of both sides in this question to get x by itself. So e goes away and I'm left with log e of 72. Now, the new thing about these logarithms in the later exercises is that there's a special name for log e, and you've probably come across it before. It's called ln, or ln as some people call it, or ln. Instead of log e, people write ln 72. Okay, so if you see, for example, e to the power of 2x equals 5, we're going to take lns of both sides instead of log e's, people will say. So if we take lns of both sides, e goes away, I'm left with 2x by itself equals ln of 5, then divide both sides by 2. So x equals half ln 5. Okay. So let's just try another example. Here, if we take log 7's of both sides, that 7 would go away, and I'd be left with the power. So 2x minus 1 equals log 7 of 23. And then you just solve for x like you normally would. Plus 1 to both sides, divide both sides by 2. 2x equals log 7, 23 plus 1, x equals half, bracket, log 7 of 23 plus 1. So, with e, same thing. Take lns of both sides first. So if I take lns of both sides, e goes away. 2x plus 3 equals ln of 7, minus 3 both sides. 2x equals ln of 7 minus 3, divide both sides by 2. X equals half ln of 7 minus 3. Now, sometimes you might end up with these kinds of questions. What you have to identify is that this is really a quadratic in disguise. Okay, so we can turn this into a quadratic, and I'll show you why. So as soon as you kind of see to the power of 2x into the power of x, you have to realize that, okay, this is a substitution question. I'm going to say that e to the power of x equals y. I'll show you why that is the case. If I call e to the power of x y, first of all, this will just turn into 5y. So I'm going to write plus 5y. I'm going to bring that 14 to the other side, so make it equal to 0. So minus 14 equals 0. And this e to the power of 2x, what would that become? I called e to the power of xy. What do you think y squared would be? Okay, I'm just squaring both sides here, right? So y squared would be e to the power of x squared, and then you times the powers, right? So that would be e to the power of 2x. So instead of e to the power of 2x, I'm going to write y squared. And look, through that substitution, we just turned this whole question into a quadratic. Okay, and we just solved that as you would in any quadratic question. I believe this is the case, and if you solve that, you get y equals 2 and minus 7. But remember, of course, we said y is actually e to the power of x. So instead of y equals 2, y equals minus 7, e to the power of x equals 2 and minus 7. So that actually means if we take ln of both sides, e to the power of x equals 2, so x equals ln of 2. And if we take ln of both sides again for the other value, you get x equals ln of minus 7. But as you should know, you can't have ln of a negative number. This is something that you have to, if you don't know that, please memorize that. You can't have ln of a negative number. This is because e to the power of x looks like this, and ln of x looks like this. Okay, so can you see that it kind of looks like there's an asymptote here at x equals 0. So there's no such thing as ln of minus 7. It has no value. Okay, so we reject that. So let's try this again with this question. Straight away we say y equals e to the power of x. So that would turn into y squared plus 8y plus 12 equals 0, and you just solve that like a normal quadratic. 0, y equals minus 6, and y equals minus 2. So, and it looks like this question has no roots because, well, that's strange, but that's fine. This question just has no roots because e to the power of x equals minus 6, e to the power of x equals minus 2. So that means x equals ln of minus 6 and ln of minus 2, but as we just said, there's no values for that. So this equation has no solutions. Okay, now the last part about logarithms is the graphs. Now, the point of a logarithm sometimes is you have these two types of graphs. Okay, we have, let's pretend that in both cases a and b are constants. In other words, they're just numbers, right? So just try to imagine in your head that a and b are just numbers the whole time. So for example, y equals 2x to the power of 3. You can imagine what that would look like, right? Or y equals 2 times 3 to the power of x. You can imagine what that would look like, right? This one might look like this, okay? And this one is just a number times an exponential, so it might look like that. How log comes into play here is that it converts these two graphs that I just drew, okay? It converts these two graphs, let's just make it smaller, and makes them linear, okay? So I can convert this cubic graph into a linear graph with this having the same information, okay? So it's a bit of a weird concept to think about, but basically in statistics, statisticians like to sort of convert between curved data and linear data because they find that linear data is easier to read. So we'll explore that in this video. So let's do that. So please, throughout these examples, just try to imagine in your head that a and b are just constants that will help you understand this video. So I'm going to convert this into a linear type of form, a linear type of graph form. I'm going to do that by taking logs of both sides. When I say logs, I mean log base 10, but log, I'm just going to say log, I'm going to take logs in general. You should know that log just means log base 10. So I get log y equals log of the right hand side, ax to the power of b. I'm going to carry on. I'm going to try to simplify it as much as I can. So log y is already simplified. This you can simplify a lot because you have the logarithm rule here where you can split a product into the addition. Okay, so this is log a plus log x to the power of b, and you can bring this power down. So this becomes log y of equals log a plus x, sorry, b log x. And that's the most you can simplify it. So it will make sense a bit later on, but you have to be able to go from this to this. Okay, whenever you see a logarithm question and it asks for, you know, converting exponential into logs, this is the process you have to memorize. What we're going to do is we're going to do the same thing for the right hand side. Okay, so right now we've got this form. Let's do it for this version. We're going to take logs of both sides. So log y equals log a b to the power of x. Keep simplifying. So log y equals log a plus log b to the power of x. And then finally bring the x down just like we had in the other version. Log y equals log a plus x log b. Okay, so these are the two linear forms of the original graphs. Let's try a question on this, and it will start to make a bit more sense. So the table below is some information about cities, ranks, and population. Okay, let's have a look at this. This is the interesting part. They say that R equals a p to the power of n, where a and n are constants, so they're just numbers. So in other words, we kind of have that y equals ax to the power of b sort of equation, right? Because if a and n are constants, that must mean r and p are not constants. What's the opposite of constant? Is variable, right? So they're variables, just like y and x. So what is the point of y equals ax to the power of b? It's probably gonna have to do something like this, right? At some point in the question. Okay. So let's just carry on. Just keep that in mind. Part A, draw a table giving values of log r and log p to 2 decimal place. Now this is a bit of a sort of silly question, you could say, to be honest. Not silly, but it's not testing you on much. It just literally says write log r, write log p, and just fill it in. So what I mean by fill it in is this is 2, right? So instead of 2, I'm going to write log 2, or I'm going to work it out actually using a calculator. This is a million. I'm actually just going to work out what is log of a million. Do you see the pattern, right? This is 3. Instead of 3, I'm going to write log 3. This is 730,000. Instead of 730,000, I'm just going to write log of 730,000. And you get the point, right? The point of part A basically is for part B, where they say plot your log r against your log p. So let's I already got a sort of picture of what that would look like, so I'm gonna just paste that in here, and just drag that up here. Let's say, so that's our part B done. We plotted log r against log p, and this is what it looks like. So can you see that this is very linear? Okay, if I plotted this normally, that would most likely have looked something like this, maybe. Okay, but because they made me plot the log r against the log p, it looks linear now. Okay, and I can just undo the logs to make it look like the original. Okay, so part C says use your graph to estimate the values of a and n to 2 significant figures. Now, this is where we're going to sort of use the log forms we were looking at before. And I'll show you exactly how and why we use it. So what I want to do is I'm just going to bring this to this side a bit. And I want you to pay attention to this r equals ap to the power of n. They say where a and n are constants. Can you see that? That's literally what they say in the question, where a and n are constants. That means r and p, the other two letters, aren't constants, right? They are variables. Okay, so it kind of resembles this y equals a, p is a constant, right? So I call it x to the power of, and n is a constant, so I call it b, right? It's exactly like the first half we were looking at before. The first example. Now I'm going to pretend it was the first half, and I'm going to find the log form of this r. So I'm going to take logs of both sides. I'll get log r equals log a p to the power of n. And I'm going to keep simplifying it. Log r equals log a plus log p to the power of n. And finally log r equals log a plus n log p. Okay, now there's something you have to know. When you convert these log questions, convert the formulas into logs, you have to put it in terms of y equals mx plus c. So this is something you kind of have to remember. It seems a bit strange, but after you do a few more questions, it will start to make a bit more sense. So we just put it in log form. We have to make this log form look like y equals mx plus c. Okay, we have to make it look like that. What do I mean make it look like that? Well, remember we said log r is a variable, so basically that resembles the y, so that's fine. And we said that we said that p was a variable as well. We said r is a variable, so log r is a variable. We said p is a variable, so that means log p is also a variable. What is the variable in y equals mx plus c other than y? It's x. So I'm going to make it log p sort of go in that position. Log p. What was in front of the log p was the n. Okay, this is making a bit more sense now. Okay, m was a constant, n is a constant. X is a variable, log p is a variable. We have the plus c. What's the only thing left? The log a. N log p plus log a. Okay. So basically we just rewrote this as log r equals n log p plus log a. So why did I do this? I'll show you exactly why I've done this. The question says use your graph to estimate the values of a and n. Well, what is plus c and y equals mx plus c? That's the y-intercept, right? So what do you think log a is? That plus log a by itself. That is also that y-intercept. Log a must be equal to 6.2. Okay? Remember, they said they don't want a. They want, they don't want log a, they want a. So how do you get a out of log a? You take it out of log form. So a equals 10 to the power of 6.2. Okay? You take tens of both sides, as I call it. How do you find out the n? Well, what is n in terms of y equals mx plus c? That's the m. N is the m. And what is m? M is the gradient. So that just means if I work out what the gradient is of this graph, it should give me n straight away. Because n is not n, it's not log n, it's literally just n. So you just pick 2 points on the graph and you just literally work out changing y with changing x, and that will give you what n is. Okay. I don't have the values in such. If I just pick two random values, let's just say 6.2 comma 0, sorry, 0 comma 6.2, and let's say also easy value, let's say 0.75 comma 5.7. So if I do changing y with changing x of that, you should get minus 16 over 5. So I get the gradient is minus 16 over 5. Remember, the gradient is literally n, 16 over 15. And they want two significant figures. So you'll get minus 1.1. Also for A, if you put that into two significant figures, you will also get you'll get 16. That's quite a big number. I believe that's million. You'll get 1.6 million. So we just worked out what A and M is. So as you can see, it is a bit confusing how they link and why they link, but basically whenever they say can you estimate these two values, you just have to remember, okay, how do I make this log form look like y equals mx plus c? And once you make it look like y equals mx plus c, it's got something to do with the y-intercept, and it's got something to do with the gradient. Okay, let's try one more example. The question says the graph represents the growth of a population of bacteria. P over t hours, the graph has a gradient of 0.6 and meets the vertical axis at 0.2 as shown. A scientist suggests that the growth can be modeled by the equation P equals AB to the power of t. P equals AB to the power of t, where A and B are constants. So it's exactly like that. Y equals AB to the power of x situation. Instead of y, they just wrote P. Instead of x, they just wrote t. Okay. Write down the equation for the line. Okay. Well, this is clearly not a line. Remember, y equals AB to the power of x, some curve. What do they mean by the line? That means put it into log form. So take logs of both sides. We'll get log P equals log AB to the power of t. And just keep simplifying. Log A plus log B to the power of t. Keep simplifying. Log P equals log A plus t log B. Okay. Just to clear things up, this is technically the line. Before we go to part B, let's just see how does this sort of correlate with y equals mx plus c. Okay, remember line is y equals mx plus c. We have it in log form. Let's see what the correlation is. So I'm just going to write y equals mx plus c and compare it with my line. They said a and b are the constants, right? So log a is a constant then, and log b is a constant. Log a is by itself, c is by itself. Okay, so log a must have been the plus c. Do you see how we sort of derived that? Log a must have been the plus c because it's by itself. And that makes sense because t log b, let's try and make sense of that now. This t log b. Okay. T log b was a constant, right? What else is a constant? X is not a constant, m was the constant. So that means log b must have been m. So, and t is the variable, and we already know it's the variable because we knew that, we said that. So let's just bring t to the other side. This basically is the equation of a line, but in log form. Okay, we've literally worked out the equation of the line in a y equals mx plus c form. Okay, so we'll keep this in mind basically. Part B, using your answer in part A or otherwise, find the values of A and B, giving them to 3 significant figures where necessary. Now, what they're trying to say is work out what A and B is, because they've given you a lot of information in the first 3 or 4 sentences. They said that the graph has a gradient of 0.6. Gradient of 0.6. Now, when we were doing that rearranging, right, what did we say the gradient was? What did we say the gradient was? It's the thing in front of the variable. What's in front of the variable? Log b. So that means not only is the gradient 0.6, log b is 0.6. Can you see how this y equals mx plus c is helping us? Okay, when you put it in log form, just think, okay, how does this correlate to y equals mx plus c? What would be my m? What would be my c? What is my x? What is my y? Okay, it sort of comes together. Log b is 0.6, so that means take tens of both sides. That means b is 10 to the power of 0.6. And then they also said in the question, if you're also wondering how did I know the gradient 0.6, that's where it said it, and meets the vertical axis at 0,2. What do you think that is? That is, of course, the y-intercept. And what did we say the y-intercept is? We said it's log a. So that means, of course, log a equals 2. Take tens on both sides. A equals 10 to the power of 2. Sorted. We have a and we have b. Part C, interpret the meaning of the constant a in this model. We worked out what a is, and you kind of have to relate it back to, well, what was the model? It was this p equals ab to the power of t thing, right? What would that look like? What would y equals ab to the power of x look like? Remember, a and b are just constants, so just pretend it was some random numbers. 2 times 3 to the power of x. What would that look like on a graph? I'll tell you exactly what that looked like. It'll look like this. So what would a sort of represent? That would represent the y-intercept. Okay. So this graph is about growth of population of bacteria. What would the y-intercept be? It's the initial population, isn't it? So that a that we worked out, 10 to the power of 2, which is 100, the initial population of bacteria was 100 of them. Okay, and there we have it.